Welcome to solution session. So in the yesterday class I discussed regarding solution some topics and questions, and today I want to continue the remaining part of the solutions. So let us discuss the 25th question. In the yesterday's session I completed total 24 questions, and in the today's session I want to try to complete minimum 30 questions, 35. See first, see 25th question. The vapor pressure of ethanol and methanol 42 and 88.5 mm of Hg respectively. So an ideal solution is formed at the same temperature by mixing 46 grams of ethanol with 16 grams of methanol. The mole fraction of methanol in the vapor phase is, that is the question. So that is the question. First of all, ethanol C2H5OH, ethanol, its molecular weight is equal to 46 gram per mole. 46 gram per mole. And methyl alcohol CH3OH, its molecular weight is 32 gram per mole. And let us calculate the number of moles of ethyl alcohol. Number of moles of ethyl alcohol is equal to how much? Number of moles of ethyl alcohol is equal to its mass 46 divided by 46 is equal to 1 mole. Number of moles of methyl alcohol is equal to, given weight is 16 and its molar mass is 32. So then how much we'll get here? 1 by 2, half we will get. Number of moles we calculated. Number of moles of alcohol, ethyl alcohol, 1 mole. Number of moles of methyl alcohol, half mole. Now, so they are going to ask the mole fraction of the methanol in vapor phase. Vapor phase. So first of all, according to Raoult's law, we can write P total is equal to P1 naught x1 plus P2 naught x2. x2. P1 naught x1 plus P2 naught x2. First one they given about the 42 is the vapor pressure of the ethanol. So then ethanol vapor pressure in pure state 42 into its mole fraction. Number of moles of ethanol equal to 1 and total moles are equal to 1.5. Total moles 1.5 plus vapor pressure of the methanol is how much here? Vapor pressure of methanol is equal to 88.5 into its moles 0.5 divided by total moles 1.5. If we simplify this, how much total pressure we will get? 57.5 we will get. Just you simplify it and you will get 57.5. So that is the total pressure of solution. Total pressure is 57.5. But they are asking vapor pressure in here mole fraction of methanol in vapor phase. To get it, vapor pressure in mole fraction of the methanol in vapor phase is equal to, this is the formula. It's partial pressure of methanol divided by total pressure. It is the formula. What is the partial pressure of the methanol? Partial pressure of methanol. So let us see here, 88.5 into 0.5 divided by 1.5. Partial pressure of methanol equal to 88.5 into 0.5 divided by 1.5, and total pressure is equal to 57.5. So it is the total pressure. Total pressure. So then if we simplify we will get the answer. The mole fraction of methanol in the vapor phase. If we simplify this, we will get the answer. How much we will get? 0.467 we will get. 0.467. Okay. Just see this. After simplification of this, how much we are going to get, So not this value. We are going to get after simplification, we are going to get this much of value. So this total equal to 44.25 divided by 86.25. Then if we simplify this, how much we'll get? 0.513 we will get. That is the answer. So therefore, the correct answer is for this question. Option C is the correct answer. Instead of it, if they ask mole fraction of the methanol, means ethanol, if they ask ethanol, the correct answer first option. But they asked about the methanol, therefore the correct option is 0.513 is the correct option. Okay, this is the question number 25. And let us go for question number 26. Let us see question number 26. So, what is the question number 26? See this. Vapor pressure of solvent containing non-volatile solute is non-volatile solute. See, it is a pure solvent. This is the pure solvent. To the pure solvent, whenever we add some non-volatile solute, then vapor pressure, what happens? Decreases. Vapor pressure is going to decrease because the surface area of the solvent is occupied by the non-volatile solute. Therefore, vapor pressure is going to decrease. The correct answer, option B, less than the vapor pressure of the solvent. B is the correct answer for that question. Next one, question number 27. Question number 27. Question number 27. So what is the question? See this. The relative lowering in vapor pressure is equal to mole fraction. Actually, RLVP, relative lowering of vapor pressure, is equal to mole fraction X2. RLVP is nothing but P naught minus PS divided by P naught is equal to, we can write what? X2 we can write. What is the X2? X2 is nothing but mole fraction of the solute. Mole fraction of solute it is. Mole fraction of the solute. So the correct answer for this question for 27, so option C is the correct answer. Next one. Question number 28. Question number 28. the boiling point of benzene C6H6, methyl alcohol, and aniline C6H5NH2 and C6H5NO2 are 80 degrees Celsius, 65 degrees Celsius, and 184, 212 respectively, which will show highest vapor pressure at room temperature. Here, how is the relationship between boiling point and vapor pressure? Vapor pressure and boiling point both are inversely proportional. Inversely proportional. This is the relationship. If there is a lower vapor pressure, then boiling point is high. If the boiling point is low, vapor pressure is high. Generally, substances volatile substances have lower boiling points, and higher vapor pressure generally. So here in this which is having lowest boiling point, 65 degrees Celsius is the lowest boiling point, 65 degrees Celsius, and methyl alcohol is having highest vapor pressure. The correct answer for 28th question. So which is the correct answer? CH3OH is the correct answer for 28th question. Option B is the correct one. Next one, question number 29. Question number 29. An aqueous solution of methanol in water has vapor pressure. Vapor pressure. See, in this question, actually, uh, two components are involved. First component is methanol, and next component, this is the methanol and water, both are involved. Alcohol and water can produce alcohol plus water. This mixture can produce solution, and that solution is going to show positive deviation. Like this, the solution is going to show the positive deviation from Raoult's law. Positive deviation it is going to show. So therefore, the vapor pressure of the solution is more than the water. Option C is the correct answer for that. Option C is the correct one. Vapor pressure increases more than that of water. Vapor pressure is. That is the question number 29. Let us go for question number 30. 30. Yes. See the question. When a substance is dissolved in a solvent, the vapor pressure of solvent decreases. Vapor pressure is decreases. This brings what happening? When a substance is dissolved in a solvent, the vapor pressure of solvent decreases. So it increases the boiling and increase the boiling point of solution, and decrease the boiling point of solution, increase the freezing point of solution. So which is the correct answer? The correct answer is, if we dissolve one solvent, if we dissolve one in the solvent, if we dissolve one substance, its boiling point increases, because pressure decreases, therefore boiling point what happens? Increases. So therefore the correct answer for the 30th question, option A is the correct answer. Next to question number 31. Question number 31. So question number 31. Boiling point of water is defined as the temperature at which. So what is the boiling point? Boiling point means what? Boiling point of water is 100 degrees Celsius. So it means at 100 degrees Celsius, water is going to show the atmospheric pressure. Its pressure equal to atmospheric pressure. So here, then the correct answer for this question, Vapor pressure of water becomes equal to atmospheric pressure is the correct answer. Option A is the correct answer for that question. Next, question number 32. This questions related to Raoult's law, ideal and non-ideal solutions. See, next question. A solution of sulfuric acid in water exhibits, say, H2SO4 plus water. Next one, HNO3 and water, H2O. So these HCl plus water, they are going to show negative deviation from Raoult's law. Negative deviation from Raoult's law, they are going to show. Therefore, the correct answer for this, option A is the correct answer. 32 question. The solution of sulfuric acid in water exhibits which type of deviation? Negative deviation from Raoult's law. The correct answer for that question, option A is the correct answer. Next one, question number 32 over 33. 33. Binary liquid mixtures which exhibit positive deviation from Raoult's law boil at a temperature than expected boiling point. Okay. So what is the question here? Binary liquid mixtures exhibit positive deviation from Raoult's law, boil at a temperature than expected. So they are going to boil at a lower temperature only than the expected. If any solutions are going to exhibit a positive deviation from Raoult's law, then what happens? Their boiling point decreases, because so vapor pressure is increases. That is the reason what happens, boiling point decreases. Therefore, they are boiled at lower the temperature than expected. At lower temperature only they are going to boil. The correct option for the 33 question, option A is the correct answer. Option A, correct one. Next, let us go for next question. Which of the following is not correct for ideal solutions? Which of the following is not correct for ideal solution? Question number 34. In case of ideal solution, Raoult's law is obeyed for entire concentration range and temperature. This is the correct one. Next one, delta V mixing is 0. This is also correct. This is also correct. And delta H mixing also 0 for ideal solution. But option B is not a correct one. Actually, delta S mix is equal to positive. It is equal to positive. What is the delta mix? What is the meaning of delta S mix? Entropy of mixture. Entropy of mixture. Entropy increases if we prepare one solution, either ideal solution or any, then by mixing the substances, if we prepare solution, so its interactions will be changes na? That is the reason what happens, entropy will be change. Delta S mix is equal to not equal to 0, but the given delta S mixture is equal to 0, entropy increases. So the correct option is delta S mix is equal to positive, but here they given delta S mix is equal to 0. Therefore, the correct option, B option, we have to select for this question. It is not correct. Next, let us go for question number 35. 35. Which of the following conditions not correct for ideal solution? Yes. No change in the volume on mixing. Delta H, delta V mixing is 0, correct. No change in the enthalpy of the mixing, that is also correct. They obeys Raoult's law, that is also correct option. Then last one, what is that? Ionization of solute should be occurs to small extent. Ionization is not required, no need of ionization. So that is the reason the correct answer is option D is the correct answer for this question. And remaining all are perfectly they are going to explain. But here then they given not correct. Therefore, we have to select the fourth option. We need to select. Next, after this, let us see the question number 36. So 36 is also one of the best question. See this 36. An ideal solution was obtained by mixing methanol and ethanol if the partial pressure of methanol and ethanol are 2.619 kilopascal and 4.556 kilopascal respectively. The composition of vapor they are asking in the terms of the mole fraction they are asking. Okay. So first of all, what is the total pressure? Let us calculate here. Total pressure is equal to here. In the question, what the data they given, just I am going to write partial pressure of the methanol is equal to how much they given in the question. Partial pressure of the methanol is equal to 2.619 kilopascals they given. Next one, partial pressure of the ethanol is equal to how much? It is equal to 4.556 kilopascals they given in the question. So total pressure, how much we'll get here? If we take the sum of these two, how much we'll get? Total pressure. Total pressure is equal to 7.175 kilopascals we will get. Total pressure is this much. Total pressure. So next one, what we have to calculate? Here we have to calculate mole fraction of the methanol. Mole fraction of methanol, if you want to get, what is the way to get it? Its pressure 2.619 divided by total pressure 7.175. Total pressure. Its pressure by total pressure. So then if we simplify, how much we'll get? 0.365 we will get. It is in case of methyl alcohol. And what is the value we will get in case of ethyl alcohol? 1 minus 0.365. If we do it, we will get 0.635 we will get. So the correct option for this question, what is the correct option? 36. Correct answer is option B is the correct answer. So it is the way of solving the problem. Total pressure, then after that vapor pressure of the methanol 2.619 divided by 7.175, then we will get the answer. Next, let us see the question number 37. So very simple and direct question. It is 37 question. An ideal solution, it obeys Raoult's law. That is the correct answer. It is going to obey Raoult's law. Next one, question number 38. Question number 38. Yes. Pure water will boil at 101.5 degrees Celsius at which of the following pressure? At which of the following pressure? That is the question. Actually, water boiling point is 100 degrees Celsius. 100 degrees Celsius. At 100 degrees Celsius, it is going to exhibit 1 atmospheric pressure or 76 centimeter of Hg. It is going to exhibit 1 atmosphere, that is equal to 76 centimeter of Hg. 760 mm of Hg. See here boiling point what happened? Increased 101.5 degrees Celsius. Boiling point increased means vapor pressure also increases. So then what is the correct answer for that question? 76 centimeter, greater than the 76 centimeter of Hg is the correct answer. Why not 76 centimeter of Hg? Because 100 degrees Celsius only 76 centimeter of Hg. Why not lower? Lower is not possible. Here 76 mm of Hg is not our answer. Actually 760, 100 degrees Celsius only 760. So it should be greater than 760 mm of Hg. So in the given option, so which one we need to select the finally? Greater than 76 centimeter of Hg is the correct answer for it. Okay. Temperature is boiling point is raised, so therefore vapor pressure also should be increased. How they are related? Here vapor pressure and temperature, like this they are related. Vapor pressure and temperature. The vapor pressure of the water, whenever is reaches to 1 atmosphere, that point is known as its boiling point. Boiling point 373 Kelvin or 100 degrees Celsius is the boiling point. Like that we can solve this question. And next let us go for 39 question. Question number 39. When 1 mole of non-volatile solute is dissolved in 3 moles of solvent, the vapor pressure of the solution relative to the vapor pressure of the pure solvent. Okay. When 1 mole of non-volatile solute is dissolved in 3 moles of the solvent, the vapor pressure of the solution relative to the vapor pressure of the pure solvent. First of all, which formula we need to solve the question number 39? To solve question number 39, we have to remember this formula P naught minus PS, P naught minus PS by P naught is equal to mole fraction of the solute. It is the formula. Okay. Mole fraction of solute uh, P naught minus PS by P naught is equal to mole fraction of solute is how much? Mole fraction of solute in this 1 mole of non-volatile solute is dissolved in 3 moles of the solvent. 1 divided by total moles equal to 4 moles. 4 moles. Next, let us simplify this. P naught minus PS, we can write P naught minus P naught by P naught minus PS by P naught, we can write that is equal to 1 by 4. This one we can cancel, 1 minus PS by P naught we will get, that is equal to 1 by 4. So then if we rearrange like this, PS by P naught is equal to 1 minus 1 by 4. 1 minus 1 by 4, what we will get? 3 by 4 we will get. 1 minus 1 by 4, take the LCM and simplify it, then you will get 3 by 4. PS by P naught is equal to 3 by 4. So PS is the vapor pressure of the solution. PS is vapor pressure of solution. P naught is the vapor pressure of the pure solvent. Pure solvent. So therefore the correct answer for this question, option C is the correct answer for this question. 3 by 4 is the correct answer. Next to question number 40. Yes. See this. Solutions distilled without change in the composition, distilled without change in composition at a temperature are called as azeotropic mixtures. So in case of azeotropic mixture, by using distillation, we cannot separate that. So therefore, there is no change in the composition of that solutions. So that solutions are known as azeotropic mixtures. They are called as. That is the question number 40. Next one, let us see question number 41. Which pair shows a contraction in volume on mixing along with the evolution of heat? So contraction means delta V mix is equal to negative, and delta H mix is equal to negative. Evolution of heat means exothermic reaction. So which option is the correct answer for that question? All is the correct answer. Because whenever we mix water and HCl, H2O and HNO3, chloroform and C6H6, so they are going to show which deviation, negative deviation from Raoult's law, negative deviation they are going to show. That is the reason the correct answer for this question, option D is the correct answer for this question. Next to question number 42. Let us see the question number 42. Azeotropic mixture of water and HCl boils at 381.5 Kelvin. By distilling the mixture, it is possible to obtain. So, actually, this is a azeotropic mixture. We can't get either HCl or water by distilling it. Therefore, the correct answer neither HCl nor water is the correct answer. Azeotropic mixture, by distilling we can't separate that component. HCl and water is the option C is the correct answer. Neither HCl we can't get nor water also. Next question number 43. These are related to elevation in boiling point and depression in freezing point. Question number 43, let us see. Which of the following is not a colligative property? The correct answer, ebullioscopic constant Kb is not a colligative property. Except that delta Tf, phi, delta Tb, these three are colligative properties. Next one. Solute when dissolved in water. Solute when dissolved in water, what happens? When solute dissolved in water, vapor pressure, increase the vapor pressure of water, wrong it is. Decreases the boiling point of water, wrong. Decreases the freezing point of water, this is the correct answer. Freezing point decreases, we discussed already, delta Tf depression in freezing point. So correct answer for that 44 question, option C is the correct answer. Next let us go for question number 45. Elevation in boiling point method is used to elevation of boiling point method is used to determination of molecular weight. So here elevation of boiling point we are using to get the molecular weight. Then which option is the correct answer? Non-volatile and soluble solute. So compulsory we have to use non-volatile and soluble solute only we have to use. So the option which is the correct answer for this question, non-volatile and soluble solute we need to use. Then only we can get the molecular weight, we can get the elevation of boiling point all. So therefore the correct option for 45 is which one? Option A is the correct answer. Option A is the correct one for 45 question. This is the correct one only. Next one, which statement is incorrect for the question number 46? Which statement is correct for the boiling point of solvent containing a dissolved solid substance? Boiling point elevated. So whenever, which statement is correct? Containing a dissolved solid substance. Whenever a solid substance dissolved in the solvent, boiling point is increases. So boiling point is increased, nothing but elevated. Option B is the correct answer for the 46th question. Next one, question number 47. Question number 47. In cold countries, ethylene glycol is added to water in the radiators of the cars during the winters. It results. What is the use of ethylene glycol? It lowers the freezing point. So then we can protect the conversion of water into ice. That purpose only, ethylene glycol is used as an anti-freezing agent. So ethylene glycol when mixed with the water, it what happens, it leads to the depression of the freezing point. Therefore we can stop the formation of the ice and we can run the vehicles continuously. So question number 47, answer option D is the correct answer. Next question number 48. Question number 48. The molar elevation or depression constant depends on the molar elevation constant or depression constant. So Kb or Kf, they are depends on only nature of the solvent. They are related to nature of the solvent. They does not depends on the nature of solute to temperature. So they are related to only nature of the solvent Kb and Kf constant. Therefore, the correct answer for 48 A is the correct answer. An example for colligative property, question number 49, which is the colligative property. Osmotic pressure is an example for colligative property. Question number 50, next to the it is related to osmotic pressure. The passing of solvent particles through semi-permeable membrane is called. The passing of solvent particles through semi-permeable membrane is called osmosis. Osmosis. 50 question answer, osmosis is the correct one. In case of osmosis, solvent molecules move from. So this is the very important question. Solvent molecules move from. Actually, osmosis occurs whenever a diluted solution, diluted solution and concentrated solution separated through the semi-permeable membrane. So diluted solution is having diluted solution and so concentrated solution. From where to where osmosis is going to occur? From diluted solution to concentrated solution, there is what happens, osmosis is going to occur. Diluted solution to concentrated solution. Here, diluted solution means it contain less quantity of this solvent, means solute. Solute is less amount. Then here solute part is more. Solute is less means it has high vapor pressure. Vapor pressure is high because solute is less. Solute is less, therefore vapor pressure is more. Next one, in case of concentrated solution, solute quantity is more, therefore vapor pressure is less. So, how the osmosis is going to occur, from where to where it is going to occur? From higher vapor pressure to lower vapor pressure occur. Diluted solution is with high vapor pressure and concentrated solution with low vapor pressure. So this is the correct option for 51 question. Option A is the correct one. Next one, let us go for Question number 52. If mole fraction of solvent in the solution decreases, mole fraction of the solvent in the solution decreases. Mole fraction, the percentage of solvent decreases in the solution, then vapor pressure, what happens? Increases, or boiling point decreases, osmotic pressure increases, all are correct. So which option is the correct answer for this? Mole fraction of the solvent is decreasing, means vapor pressure of the solution decreases. Boiling point, what happens? Boiling point increases. Osmotic pressure, what happens? Increases. Osmotic, because concentration is increasing na, so therefore osmotic pressure. So in this question number 52, 52, mole fraction of the solvent in the solution decreasing, means concentration we are increasing. Concentration of the solution we are increasing. Concentration of solution increases means only one, that osmotic pressure is going to increase. How it is going to increase? How we can say? Here there is a relation, mathematical relation, pi is equal to CRT. Pi is equal to CRT, and osmotic pressure and concentration, they are directly proportional at constant temperature. So therefore, one and only option, means in this option C, osmotic pressure is increases is the correct answer. Next one, question number 53. 53. Two solutions have different osmotic pressure, then two solutions have different osmotic pressure. Higher osmotic pressure is called as hypertonic solution. If higher osmotic pressure is there, P1 is having higher osmotic pressure than the P2, then it is called as hypertonic solution. Hypertonic solution. This one is called what? Lower osmotic pressure is there, means it is known as hypotonic solution it is. That is a question number 53. Hypertonic solution. Next 54. 54. According to Boyle and Van't law for solution, osmotic pressure of dilute solution. Osmotic pressure is equal to CRT, and C is equal to N by V RT. Osmotic pressure, how it is related with the volume? Inversely proportional. So therefore the correct answer, inversely proportional to its volume, is the correct answer. Option A is the correct one for 54 question. Next 55 question. 55. So now onwards, the questions are related to want of factor, and we can expect in examination. Which solution will show maximum elevation in boiling point? Which one is going to show maximum elevation in boiling point? ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಲಿವೇಶನ್ ಅಂದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ, ಎ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ increases means it should contain more number of particles. More number of particles should have. So then how we can select the correct option here? All are having same concentration. Same concentration is there. We have to select the number of particles in which more number of particles are there. That one we have to select. In case of KCl, only K plus and Cl minus, only two particles are there. But if you take option D, It is ferric sulfate. In ferric sulfate, Fe2SO4 taken 3 times. How many number of particles we can get? 2 Fe plus 3 and 3 SO4 minus 2. Total number of particles are equal to how much? It is equal to 5 particles. So number of particles are greater. Therefore, the which option is the correct answer for this question? Option D is the correct answer. For 55 question, option D is the correct one. So because it has more number of particles, the correct answer is D is the correct one. Next, let us go for question number 56. 56. Which of the following, the next two remaining questions are related with related to Vanta factor? Which of the following 0.1 molar aqueous solution will have lowest freezing point? Lowest freezing point. Freezing point is lowest. So then which option is the correct answer for this? Correct answer is potassium sulfate. Why? What is the reason? Potassium sulfate, what is the reason? Reason is here K2SO4, potassium sulfate. It is going to produce how many particles? 3 particles. 2K plus SO4 minus 2. Number of particles are 3. More particles, less is the freezing point. Freezing point decreases more. Next, in case of sodium chloride, only 2 particles will get. I factor for sodium chloride is 2 only. I factor means I is the sodium factor, Vanta factor for sodium chloride equal to 2. Then what is the Vanta factor for urea? Vanta factor I for urea 1, for glucose I is equal to 1. Only for potassium sulfate I Vanta factor is equal to 3. More the Vanta factor and its freezing point is lower. So the correct option for the question number 56, option A is the correct answer. Next one, question number 57. 57. The correct relation between boiling point of very dilute solutions of AlCl3, CaCl2. So first they are asking directly boiling point. Boiling point they are asking, then we have to see the I factor, which is having highest I factor, means I value Vanta factor, that is only is going to have highest boiling point. Boiling point is highest for which substance is having highest Vanta factor. See, in case of AlCl3, AlCl3 can dissociated into Al plus 3 and 3Cl minus ions. Number of particles after the dissociation. What is the actual Vanta factor definition? Number of particles after the dissociation, number of particles before the dissociation. That is the Vanta factor I. So 4 by 1. 4 by 1, 4 we are getting here. In case of AlCl3, I is equal to 4. Then in case of CaCl2, what is the I? I is equal to 3. 3, which is having highest to AlCl3. Therefore, its boiling point is high. There, the correct answer for the 57 question, option B is the correct answer. Next one, question number 58. 58. Question number 58. 0 molar solution of urea is isotonic with what? So 0.5 molar urea is isotonic with 0.5 molar sugar solution. Because for urea and also sugar, urea and sugar for both Wanta factor is same, that is equal to 1. So therefore the correct option for the 58th question, 58th option B is the correct answer. Next one, question number 59. Which salt may show the same value of Wanta factor I as that of K4FeCN6 in very dilute solution? Okay, first of all, let us calculate the Wanta factor for K4FeCN6. K4FeCN6 Wanta factor is how much? So if you if we get it, so if we are going to dissolve it, it is going to split into this kind of ions 4K plus FeCN6 minus 4. Total number of particles after the dissociation we are getting 5. So 5 we are getting. In which salt we will get the same number of ions, same number of ions. So in option A we will get same number of ions in the option A. Here we will get same number of particles. How? Aluminium sulfate is going to dissociated into 2Al plus 3 and 3 moles of SO4 minus 2. Then the total number of particles are equal to 5. The correct answer, both are having same number of particles. Which one? K4FeCN6 is having same number of particles as that of aluminium sulfate. So correct option is option A is the correct answer for the 59th question. Next, let us move to the next question. Say question number 60. Which aqueous solution has minimum freezing point? Minimum freezing point they asked, which is going to have minimum freezing point. So whenever concentration is more, then its freezing point is minimum. The concentration is high, then its freezing point is minimum. So the in the given conditions, one and only concentration is high, that is 0.1 molar NaCl, and even it is dissociated into two particles. I factor for this equal to 2, Wanta factor is 2. So therefore for 60th question the correct answer is 0.01 molar NaCl is the correct one. Next one, question number 61. Let us see the question number 61. In which of the following the Wanta factor is equal to 1? Wanta factor is equal to 1. So the correct answer for this question, urea Wanta factor is equal to 1. It does not undergo decomposition. Uh, it never undergo association. As you know that if there is a dissociation, I factor is greater than 1. Next to, if there is a association, I factor is less than 1. For non electrolytes, I factor is always equal to 1, like glucose and fructose, sucrose, urea. For all these non-electrolytes, I factor is equal to 1. So the correct option for 61, option C is the correct answer. Next, let us see the Wanta factor I for dilute aqueous solution of glucose is. So what is the Wanta factor for the glucose? It is equal to 1. 1 is the correct answer. It is why it is 1? It is a non-electrolyte. For non-electrolytes, Wanta factor is always equal to 1. Next one, question number 63. 63. Yes. Wanta factor I means what? What is the meaning of Wanta factor I? Is less than 1 in case of dissociation, uh, is less than 1 in case of dissociation. This is the wrong. It is more than 1 in case of association. Wrong it is. I is equal to normal molecular mass divided by abnormal molecular mass or observed molecular mass. So this is the correct answer. For 63 question, option C is the correct answer. It is Vanta factor is a ratio between normal mass, molecular mass divided by abnormal molecular mass. Abnormal molecular mass. It is the ratio. Then next to, so next question, question number 64. In case of electrolyte, which dissociates in the solution, Vanta factor is equal to. Electrolyte is there and it is dissociating in the solution. Therefore, Vanta factor is always greater than 1. Option A is the correct answer for the question. Next one. Which one of the following salts would have the same value of the Vanta factor I for this one? Means here potassium ferrocyanide they given K3FeCN6. FeCN6. For this, what is the Vanta factor we will get? I is equal to, we will get 4. How? 3K plus ions, 3K plus, and one more complex ion, FeCN6 minus total minus 3 we will get. Total number of particles are how many? 4 particles. Then in the given options, where we will get the same number of particles? In which option we are going to get same number of particles? For suppose if we take sodium chloride, how many ions we will get? Na plus and Cl minus. Only 2 particles we will get. So therefore it is not our answer. The correct answer is aluminum nitrate. Option D is the correct one. How? Aluminum nitrate is going to split into this kind of ions. Aluminum nitrate is split into Al plus 3 and 3NO3 minus, and total number of particles are equal to 4. So same number of particles obtained in aluminum nitrate. So this is the today's session. I hope you understand and thank you for joining with us, and I am going to close the session. Thank you one and all.